All right. Hello. Today we're doing another Leetcoders video. Well, not really Leetcode. It's just another coding problem thingy. Um, we're not going to be doing subsets anymore. Same dilemma. The question that I should be doing got a little bit too difficult. Not really sure if I wanted to, break my brain doing it. So decided to hit a pause real quick on that. And so with that being said, we're going to be doing a problem called Order-agnostic Binary Search. Yeah, so let's read the problem statement, and then I have a few examples, and then we'll go through the code, we'll run it. We only have 4 because, well, this is on Leetcode, so we'll be doing it this way. And yeah, so without further ado, let us go. All right, so given a sorted array of numbers, find if a given number's key is present in the array. Though we know that the array is sorted, we don't know if it's sorted in ascending or descending order. You should assume that the array can have duplicates. Write a function to return the index of the key if it is present in the array, otherwise return -1. So yeah, we don't know if it's sorted in ascending or descending order, and then we want to just find out if we can find the key. So yeah, it's relatively simple of a problem, but without further ado, let us go. We're going to have a left and right variables. This is how I do binary search. I use left and right. Some people use start and end. Up to you, whatever you want to use. The reason why I use left and right is because mid makes more sense when I have a left and right variable. So yeah, left, obviously we start at 0 because that's the left bound. The right bound is the length of the array -1 because you can't actually go all the way to the edge of the array. So we're going to have a reverse variable is array 0 is greater than or equal to array right. Oh, so yeah, I should actually use left here because it's the same value. But yeah, we just want to check it's potentially reversed if this is greater than or equal to, because you should assume that it can have duplicates. So basically, if it's the same number from like beginning to end, it's could theoretically be considered reversed. But if it's the same number from beginning to end, it's also not reversed in a sense. So it's up to you if you want to include this or not. But basically, you could just have this, and so this is my condition for it being reversed. So in order to do binary search, we want to eventually eliminate our bounds from left to right all the way down to one number, and then if we still can't find the number there, then we'll eventually like reverse the pointer positions, and then that's how we know we've lost, that we can't find the number. Or if we do find the number, we just return early, right? So our condition is while left is less than or equal to right, because as long as that bound stays, we know that we haven't like at least crossed over yet, and so we could potentially still have a valid solution here. We're going to calculate mid, which is done with left plus right minus start, not start, left divided by 2. Whoops, I think my 2 double registered. But the reason why, we really just want to find the midpoint, which is really just left plus right divided by 2. But if there's a potential issue that can come from this, is if like these two numbers are stupidly high, you could get an overflow error. In Python, I don't think it's really as possible, I guess. But like in Java and like C++, you have int and you have long, right? And potentially even long. So if you use int and then like you hit one of those really big numbers, you will overflow and then you will get a wrong answer. So a way to essentially get around that would be doing this left plus, and then you calculate like how many indices from left is the midpoint by doing this. And then you can calculate the midpoint like this. And then it essentially guarantees that you will not overflow unless like your length here already overflowed in the first place. But theoretically speaking, that shouldn't happen, right? So this at least keeps you safe and you shouldn't overflow like that. And the reason why we do this double, I never remember if this is a forward slash or a backslash, but we do two of these instead of just one, because this type of division gives you like actual division. So if you get 5 divided by 2, it'll end up giving you 2.5. But obviously indices are in integers or like whole numbers. So if you do this, this is floor division, in which it will guarantee that whatever number you get. So let's just say with the same example, 5 divided by 2, you'll still you'll get 2, because it'll just round down to the nearest whole number. And so from here we just do if array mid, oh my god, double registered, is equal to key, then we have found our solution, so we can just return mid, and then we can just exit there if we have found our solution. And so if we have reverse, right, so if we're in reverse, then if the key is greater than array mid, then we need to go to the left, right? So we need to bring in the end bound, or like the right bound, inward, like to the left of mid, because like we know mid isn't that answer. So the most extreme that you can get from mid, but then that is still could potentially be the answer, would be mid minus 1. So you would just do right equals mid minus 1. Else, this is so since we already know it's not mid, and then we know it's not greater than, so this one will just be the less than. This would just be key less than array mid, right? So here we would end up doing left is equal to mid plus 1, because it's the same logic for this one, but then obviously the other way around, because we know that the key, wait a second, so if it's in descending order, just want to make sure the key is greater than, okay, yeah, I was getting confused myself because I forgot this is the reverse case. So if it's less than, then we know it's on the right side, right? So you just move left to mid plus 1, and then you do an else here, which is now this is not reverse or increasing, not reverse, increasing, oh no, it's ascending order. There we go. And so now if key is greater than array mid, since this is increasing order, you want to do left is equal to mid plus 1, right? And then this would just be key is less than array mid again. And so you would just do right is equal to mid minus 1. Because you know, like the bounds, if we're going like upward, you wanna, since we're going upward, you want to make the left bound to the right side of mid, and then since we're going down, we want to make the right bound the left side of mid. And at the very end, if we never find our answer, we return -1. This is the exit case. So eventually, if you you just don't ever find the number, that's what would happen. So actually, let's add another case. Binary search. Oops. Let's do whatever. We'll just do the 4, 6, 10. And then here we'll just look for 5, right? Since we can't find the number 5, and all these other ones you can find the number. So if we look at this, this should return 2. This should return 4, because 0, 1, 2, 3, 4, right? This should return 0. This should return 2. This should return -1. Right? So now, let us run the solution. 2402 -1. 2402 -1. Boom, boom. There we go. We have completed the, what is this called? Order-agnostic binary search. Yup. All right. So with that being said, I finished this problem. Thank you for watching. See you next time.